In this presentation, we're going to look at continuous random variables. X is a random variable with density function, or PDF, probability density function. I'm just going to say density function. F of x, well, that's a small x, so the subscript of an x at the f. F of x equals 2 minus x all to be cubed over 4. Just watch out for that, actually. So, over the range 0 and 2. Now, so the question is, using calculus, find the mean and variance of x. So essentially what we're looking for is the expected value and the variance of x as well. Okay, and to calculate the variance of x, what we also must do just beforehand is calculate the expected value of x squared. Okay, so that's something we have to calculate before we're able to calculate the variance of x. So let's get into it. This is using calculus, so I'm going to use integration here. Here's the general formula. Now, depending on whatever the limits are, we have an upper and lower limit. So I just left them sort of innocuous as the upper limit and the lower limit, u and l. In this case, u and l are going to be 2 and 0. The upper limit is 2, the lower limit is 0. What we're going to do here is get the integral of x times f of x with respect to dx. So we have x here. That's that x down there again. Or that, well, it would be better if it was a small x, to be honest with you. It's just the way I write it, is small x and times f of x. Small x times, no, it should be, there we go. Sorry, my pen can act up sometimes. X times 2 minus x cubed over 4. Times d of x. That's with the differential with respect to x. What we're going to do here is use a technique known as substitution. I'm going to use in this particular instance. Okay. What I'm going to do here is what we have to do is integrate that up there. That's the top part. And what I'm going to do here is use the integration by substitution technique. Okay. And rather, I could evaluate 2 minus x cubed and so on, but there's it's not particularly long to evaluate 2 minus x to be cubed. But what I'm going to do is use the substitution technique. U equals 2 minus x. Okay, so I'm going to let this part equal to u, and I'm going to rewrite that as x equals 2 minus u. Okay, just work it round. That just comes in handy later on. Also, if u equals 2 minus x, what we would also need to do over here is du over dx equals 2 minus 1. Or, in other words, du equals minus dx, or dx equals minus du. That's quite important. So, okay. So, I'm going to do this as an indefinite integral. And I'm going to leave the limits out of it. So the first part is up there, right up at the top here, is x. So we're going to replace that by 2 minus u. The next part is 2 minus x to be cubed all over 4. So I'm going to take out the 1/4 out of here, out to the side. And let's just leave it as u to the power of 3. Okay. And then finally dx is now minus du. Where am I getting that? Here. Here. So there we go. That part there. So we have minus du there. Okay. Now what I'm going to do is actually just rearrange this, and I'm also going to leave it as an indefinite integral. The reason is because it can get slightly troublesome if you want to do this as a definite integral. So what I'm going to do is treat this as an indefinite integral, disregard the limits, solve it, then put it back in terms of x, and then worry about the limits. Okay. It just actually it's sort of you get yourselves bogged down and trying to do too much or too much too quickly. So what I'm going to do is get rid of this minus sign here, okay? And what I need to, so what I could do is that would cancel out by if I was to put 2 minus u as u minus 2, which is essentially multiplying it by minus 1. 2 minus u by minus 1 gives you u minus 2. Okay? So if you just want to check that yourselves, you'll sort of find that it works. Now, so 1/4 of u to the power of 4 minus 2u over 2 times u to the power of 3 du. Okay, that's a nice, easy, straightforward one. So that is 1/4 of u to the power of 5 over 5 minus 2u to the power of 4 all over 4. Okay, and we can bring in that 1/4. That is u to the power of 5 over 20 minus u to the power of 4. 1/4 times 1/2 is 2 over 4 is 1/2. It's simply 1 over 8. Okay, so now what I'm going to do here is just put back in x, or 2 minus x. So I'm going to recall u equals 2 minus x. Okay, I had to take a quick pause there because my dogs are barking, so they're happy enough now. So back to the job, u equals 2 minus x. Let's just put that in. So that is 2 minus x to the power of 5. You don't actually have to sort of work this out. Okay, minus 2 minus x to the power of 4 all over 8. Okay, we can actually just leave it as that. Just evaluate it. Now we're going to consider the limits. 2 and 0. Okay, now that we have it in terms of x again, we'll just work in the limits again. So what we're going to do now is evaluate it, okay, for 2 and for 0. And in the first instance, what we have is 2 minus x in both terms. So when we let x equals to 2, they essentially both go to 0. Okay, here we go again. Unpaused again, dogs barking again. And so when we let it equal to 0, x equal to 0, we have 2 minus 0. Okay, so that's 2. So 2 to the power of 5 is 32 over 20. That's 2 to the power of 5. Or 2 minus 0 to the power of 5 is 2 to the power of 5. That's 32 over 20. Let's do for the other side here. 2 to the power of 4, or 2 minus 0 to the power of 4, that's 16 over 8. Okay, so that side just entirely cancels out. So going a little bit further at this, what we get is minus 1.6 minus 2, or in other words 2 minus 1.6, and that's equal to 0.4. So the expected value of x is equal to 0.4. So that is the answer to the first one, the first part there. Get the expected value of e to the x. That's the mean. So the next thing we are going to do now is, I'm just going to go down here. What we're going to do now is calculate the variance, and the first thing, as I said before, is we have to calculate the expected value of e of x squared. Okay, now this is a very similar calculation, but what I'm going to do here is actually, so what we do is an integral again, but rather than x, we would have x squared here. Okay, expected value of x, or the limit, the integration of x squared times f of x. That is to get the expected value of x. So there it is there. We put in this term here. This is the PDF here again. Okay, 2 minus x cubed over 4, and we have that there, x squared. This time what I'm going to do is I'm just going to multiply out 2 minus x cubed, okay, and it's not really that long of a calculation. Now, the last time I just put in the integration by substitution, just to sort of remind undergraduate students that that sort of stuff is very, very useful. But in this case, what I'm going to do is actually just multiply it all out. 2 minus x to be cubed is 8, minus 12x plus 6x squared minus x cubed. When we further multiply that by x squared, what we get is 8x squared minus 12x cubed plus 6x to the power of 4 minus x to the power of 5. Okay, so the expected value of x squared is the integral of that, 8x squared minus 12x to the power of 3 plus 6x to the power of 4 minus x to the power of 5 dx. And again, don't forget to put in your limits there, 0 and 2. Okay, so let's integrate that out. What do we get? 8x. Oh, sorry, we have to put in forgot the 1/4 there. Okay, I forgot that 1/4 there. Don't forget that. That's a big mistake I nearly made. So what I'll do is actually just put it outside the whole thing. Have it outside there. Okay. So 8x cubed over 3. Okay. Minus 12x to the power of 4 over 4. Plus 6x to the power of 5 over 5 minus x to the power of 6 over 6, and again we have our limits 0 and 2. Okay, so a little bit of simplification would work here, and not much scope for it really. What we could do there is get rid of that 12 and 4 and just put in a 3 here instead. Okay, but ultimately what we're going to do here is actually just substitute in both 2 and 0, okay, and then let it work it out like that. So I just have something ready down here. Do I? No, I sort of not going to use that. I'm just going to pause and scribble it out. Well, just as before I continue, for each of those four terms there, if we were to evaluate them at 0, we would just get 0. So the entire second, the lower end limit evaluation is just going to be 0. So I'm only going to concentrate on the upper limit evaluation, which is 2. So what do we have here? 1/4 times 8. X cubed is 2 cubed. That's 8 over 3. Okay. Minus 3 times x to the 4, that's 3 times 16. Okay, that should be a 3 down there. Plus 6x to the power of 5 over 5, so that's 6 times 32 all over 5. Okay, minus x to the power of 6 over 6, so that is x to the power of 6 is 2 to the power of 6 is 64 over 6. Okay. Just to be clear, the other expressions are when we evaluate it at 0, we just get something like that. So that's why we can just disregard the entire second component there. Now, really just what we need to do here is just do a bit of calculator work. Okay. So what we have here is 1/4. Let's actually just simplify it out first. So 64 over 3 minus 48 plus 6 times 32 over 5. Well, that's an awkward one. In a second. That's 32 times 1.2. I'll just leave it as is for a second. That is 192 over 5. Minus 64 over 6. Okay. And essentially all we have to do is just calculate that. So I'll just get my calculator. Working it out, actually, what we would get is 1/4 of 32 over 30. Okay, and that is actually 8 over 30. Okay, so that's the expected value of x squared, 8 over 30. So what we could do now is, just as a sort of remark, the expected value of x was, we could write it as 12 over 30. Okay, it was actually, remember, it was 0.4. Okay, and the expected value of x to be squared, well, that would be 0.4 times 0.4, and that is essentially a bit of an awkward one actually. So the 12 over 30 is actually probably not helpful. It is not equals 0.16 essentially. So what we're going to do here is to calculate the variance. What we would have here is essentially what we have to do is solve this. Now I've done it two different ways. 8 over 30 minus 0.16. A little bit of calculator work. What is 8 over 30? Actually, really, just actually leave it as a 1066. Just leave it as that. It's probably the best thing there. Yeah, right at the 4 decimal places, roughly. At least, anyway. Okay, so the expected value of x, that's the variance of x. That's the second one we need. The variance of x equals 0.1066. And we'll leave that video there. That's continuous random variables exercise.